Looks great.
Hey, Skarbek.
How's it going?
It's going well. It's Friday, our countdown till the end, so that's good. How
Yeah, I'm
about you?
looking forward to the weekend as well.
Yeah, good, good. That's a good sign that you had a fulfilling week.
Fulfilling-ish.
Good.
So, I kind of want to have a discussion. I really wish Jarv could participate in this discussion, but I'm looking for
I'm not enough
ideas.
for you anymore, Skarbek. I
Oh
can't
no,
satisfy
like you're plenty, Myron. You're plenty.
your. Cool. Cool chat.
Um, I think I'm looking for ideas or suggestions as to how to isolate and test which queues still have dependencies on NFS. I have not yet done the work to determine which queues are left on catch-all. That's kind of next on my list of things to accomplish.
Mm-hmm.
And I know it's quite a few. Let me pull up the epic if I could find it quickly. So I basically broke down things into two epics. One, migrate the catch-all shard, which we can't migrate the entire shard as is because of dependencies on NFS. And I've created in a second epic that we could capture all the ones that do live on or do require NFS, such that we have the ability to kind of shove those to the side and work on them at a later point in time.
Have you posted the epic somewhere?
Oh.
Sorry, I'm
Hang
feeling
on.
like I'm missing something here.
I'm
Okay.
like really trying hard to navigate things. Okay, the overall epic is here. I'm putting it into the agenda.
Thank you.
Discussion. So Epic 89 is the current one that we're concentrating on. It's the migrate the catch-all shard is the next in line epic, and inside of there I've got issue 1000 for evaluating which queues are running on.
Issue 1000. This is the epic, so 275, right?
Yeah, Epic 275.
We should enable design management. It's saying that in the issue.
Yo, right? Like I use it
Everywhere.
heavily.
Yeah.
On every project I use this
I
heavily.
think they should make it really big, like maybe like a whole page.
With bold. Yeah, yeah.
Yeah.
And links. And links. Sure.
I mean, it's already added so much quality to my life. Like making it bigger would add a lot more.
Oh my goodness.
Okay, so
Here, I'll
before
share my
Andrew
screen.
shares his wisdom on how to do this very methodically and quickly, I'm just looking at the shard detail page here, and I see this is basically what we have currently in there, right? All of these queues are inside of that catch-all shard.
Yep.
So,
well, that's all the queues that have run something in the last bit of time. I would imagine if a queue hasn't run anything, it's probably not going to show up, right?
Really?
That's right.
That would be odd. Oh, that's odd. Didn't know that. Well, that's great then, because that means play with the timelines and see which one is not actually doing any work and migrate that first.
I was going to do a query against Sidekick to determine what queues catch-all are running, but you know, I could do either or.
No, you do better, but basically like
there's quite a few. So
yeah, there's quite a few.
Jarv at one point mentioned maybe spinning up a secondary fleet of Sidekick servers and then moving Sidekick individual queues over and just watching NFS data come through, because we've got a metric that we could utilize to monitor NFS traffic. But with nearly 100 queues here, ballparking 100, that's going to take a lot of time and effort. And I can't think of a way to make that any easier right now.
But wait, we already have catch-all queue in VMs, right? It's current.
Yeah.
That's what's currently happening there.
Yeah, that's the remaining shard as VMs.
And we confirmed, Andrew, your microphone is bringing a lot of noise.
Sorry.
No worries. I lost my train of thought for a bit there. We know for a fact that
You have a Factorio T-shirt. That's awesome.
hey, with 800
really
hours plus
that game.
in this game, I better have a T-shirt. Anyway, what I was trying to say is VMs. We already have the shard in the VMs, right? So,
Yeah.
do we know for a fact that we have NFS reads and writes there? We do,
Yeah.
right?
We have a query. I had to remember what it is. It's been a while since I've looked at it and I did not save it. But we do have a query somewhere that we could use to validate that we are running or writing and reading from shared storage.
And do we conclusively know already which one of those, like at least one of those queues that is reading and writing?
None that I know of. I'm sure others may already know that, like Jarv. You know, we could probably safely assume that anything related to pages writes to NFS.
Yep.
But outside of that, I don't know.
Pipelines. Most likely, everything that has to do with traces. We know about that already as well.
I don't know what that means though. Like I don't know what jobs have to deal with traces.
So
trace is the build output.
Yeah.
And it buffers on disk. And in order for a web node to be able to render that, like any random web node, it actually has to have access to the NFS where this is buffered. Andrew, feel free to interject. We're just brainstorming here a bit, and I find this exercise really nice because I'm thinking like how I would investigate this. At least is probably a link. Go ahead.
Sorry, do you want to say your way? Go for it.
Yeah, go for it.
So I mean, this is what I said to Jarv, and I think this was the basis of his. Or at least when I was just talking, it's not mine, but you know, it came from the discussion between Jarv and I. You know, about running the fleet like you described, where we run some nodes, some machines in monitor, and then we have a problem where we have maybe 100 queues on there. So that's an awful lot to get through. But one of the things we could consider is, so we know the things that are problematic. We can take those out. Say that leaves us with 75 queues that we just don't know about. One of the things that we could potentially do is we could just leave the catch-all fleet running, and then we could have another fleet called catch-all 2 or something slightly more exciting than that, but whatever. And another thing that's really nice about this, catch less, catch more. Anyway, and so what we can do is, but the main thing is here, we don't touch catch-all. Catch-all just carries on running. Yeah. But then, this is one of the nice things about Sidekick, is basically we run it, and every hour, so we write a little script, which isn't too hard to write, and we turn off Chef on that machine maybe or something. And basically every hour, it rewrites its config and cycles through another one of the jobs. Right? And then after an hour, it rewrites the config, or maybe what it does is in Chef. No, so listen, hear the styles,
so
right?
The reason why we can't stop Chef is that we need to deploy to that node continuously. That's the problem.
But we don't use Chef for deploying.
We don't, but we update Chef, or we update a bunch of things in there.
Okay. So here's a really easy solution. In Chef, we make it that we have a little config for this box. And we have a special role, and the role has got the 75 queues in it. And basically we say start time is now, and we say how many hours from now is it? From start time, it's 2 hours. Go to item 2 in the list. it's 3 hours. So every time chef diverges, it will consistently diverge down through the list of the queue. You know, that part's kind of like chef people can deal with that. But anyway, so anyway, what it is like hour after hour after hour, it goes through, and then we kind of ignore like 5 minutes around the hour or something like, or we'll have to kind of take in the you know, chef doesn't run every minute. So we'll have to kind of include that. So maybe we make it 2 hours just to be like nice and safe. And we let everything run. And if it cycles over, it goes back to the beginning again. So we get the data again from scratch. Anyway, out of the back of this, we take all the NFS data that's running. This is like a bit harebrained, but like feel free to shoot it down as a terrible idea. We take all that data and we correlate it with the NFS activity on those hosts. And if there's NFS activity, then we put it in one box. And if there's no NFS activity, we put it in a different box.
So,
and that's the first step. Sorry, there's the second step as well. What's left of that is things that write to NFS, but that might be things that just write to NFS because it just needs somewhere to store things. Those are actually fine. What we have to then divide up is the things that write to NFS because they're going to share them with other things, right? That's the problematic stuff. Stuff that like if a Sidekick job comes, writes to NFS, reads from NFS, and then never sends that file reference to anybody else ever, that stuff's actually fine because it's only if it's shared across NFS that it's problematic, right? And so then the next step will be to, and there's not really a great way to do this, unfortunately. Well, there is one way, but it's kind of a bit dodgy, but I can explain that to you at a later stage. But basically then we divide it down, and the things that we decide are not being shared, we push those to one place, and then everything else we can send off. But that would automate a lot of it, right?
I mean,
I was thinking of something a bit different, which has overlap with what you're saying. So what I was thinking was doing almost like a Git bisect type of thing. So you have a sample, you have it, and you put one half on the machines, right?
But Git bisect is for finding one in many, and this is not a bisect. This is
I know,
separating the sets. Okay.
I know, but I'm trying to kind of visualize it the same way, right? Like you have a start and end. You're not going to start with 100%. You're going to take half of this, right? And then look at what you actually have in that half. See whether there is anything obvious that you already didn't clean out, meaning you already removed known dependencies, right? Like I'm starting from that assumption. Pages and traces.
75 that I spoke about.
Oh, all right, exactly. Then you look into what's there and you compare that with what we actually have covered in QA. So put that on staging and mount NFS and fire off QA against it. See whether anything explodes in Sentry, see whether there are any attempts to write to the directories where NFS would be mounted. And then if any of that happens, reduce the scope again and try again. And it's going to be manual, but it feels like it's going to be a bit faster than writing scripts that depend on chef and start and stop time, and you know. So at least that's how I would try to do it. And then everything, sorry, and then I forgot the last process. Everything that you're certain about, you migrate on staging on Kubernetes, put it on Kubernetes and monitor what's happening there.
So I think that's going to take, well, first, the two things that I'm concerned about with that. First is that we have trust in our QA, in particular for backgrounded jobs, right? So there's QA for calling a web service and making sure that it gets a 200. And then there's QA for something that happens behind the time. And I would argue that the QA that we have for immediate synchronous stuff has a low enough volume the stuff that's asynchronous is going to be even lower volume. So that's the one concern that I would have with that. I think the two can kind of be done as well. Like, but again, the thing is, like, if you don't know, like if a bisect doesn't really work, because if you have like, say 70 jobs in that set that you're trying to go through, trying to get effectively what you're going to be doing, because it's not, you're not looking for one, you're looking for many. And so effectively what you end up doing is lots of different combinations, and the number of combinations is kind of like 70 bang, you know. So I mean, it's never going to be, hopefully you never have to go through factorial 70, but that's effectively how many different combinations you'd have in that approach.
But I'm looking at the stages right now, sorry, the queues right now in the catch-all, and you can also exclude all the cron jobs at the start, right? Because you know those are gonna run at certain random point in time as well. Isolate them as well. And then
but you don't know whether they're writing NFS, right?
Yeah, we don't. I don't think anyone knows that.
But
right?
we could,
and then,
but with the approach that I suggested, you'd figure that out.
I mean, we'd figure that out through both approaches.
Yeah, exactly.
But how would the QA give you the cron jobs that are?
No, QA, like if we exclude.
QA... Go ahead, Mark.
Go ahead. No, what I wanted to say is that if we exclude cron jobs from the start, then we reduce one of the problems that you mentioned, which is QA not hitting those type of jobs. You know, there is another approach. Did we consider even figuring out to whom these queues belong to, and then asking all of those people to help us out?
Yeah, you could do that as well.
I think that might be simple than not messing with infra.
Maybe a combination effort.
Yeah, probably, while we are waiting for paint to dry.
What would be the harm in spinning up 100 VMs in just one queue per VM?
Money, but that's fine. I can work with whomever to actually justify this small.
The other thing is that you'd put a lot of pressure on like all the other things.
Yeah, I don't know how, one queue might blow up and that node would end up dying.
Yeah, but you don't have to do that. You can automate, definitely.
Yeah.
Right. That brings us then closer to Andrew's suggestion, which is like if you automate two queues at a time.
It's really not a complicated piece of code, right? It's really, it's just kind of like a little bit of Ruby with a list of 70 jobs in it, and just a consistent way of caching to it.
I think my worry with your proposal, Andrew, is that if a job comes through during that entire period, because these queues are still going to be processed on catch-all, there's a chance that the job will pick up a piece of work where by chance it doesn't need to use NFS just because it doesn't have the right arguments. Or
there is so like the project is spot on. Like I think that it would only be good for the things that are running at, like I would say we would want to get like 1,000 jobs running through that machine, right?
Yeah.
As a kind of statistical. So anything that's running at less than 1,000 jobs, 8,000 jobs an hour, would probably not be that good, because you'd want to make sure that
to run those for like a solid week on something different to analyze the NFS work on that.
Yeah,
and that's where my kind of dumb idea of 1 VM per queue comes into play for something like that, because we could just dedicate that node for just that one item.
Yeah, how about a different approach? It's a bit more risky, but instead of doing 1 queue per VM, you actually have a backup VM, and you put things in Kubernetes, not all of it at once, obviously, but part of it. And if you notice something, you run an experiment. And if you notice something erroring or depending on it, you bring the queue back into the emergency VM queue.
So create
Right?
the catch-all queue in Kubernetes,
Yeah.
but slowly move maybe one queue at a
Out.
time into it.
Or out of it, like you add everything and then you start removing. Obviously, when I say everything that we don't know, right?
Yeah.
We are still talking about pages and the other one out of this. So you start from not slowly pouring water in, but spilling all the water out. Man, this also sucks though.
And you,
yeah, like even that, there's be a long time before we may discover things. So we'd probably have to spend a lot of time and effort monitoring that particular queue and watching the logs for it, which, you know,
do we have an alternative?
so
It's
here's one other thing that's a bit, do we have BCC tools on the, we do, don't we? So here's a potential option, but it's a bit more complicated. So basically we use eBPF trace points to trace back NFS accesses, or maybe just file system accesses, to processes. And what would really help with that is if we set the concurrency of, maybe we had a second catch-all fleet, which is called catch-all 2 again. And the trick with this catch-all fleet is that the concurrency of the sidekicks are 1, because then with eBPF, we can figure out what job is running when we can go from a process to a job, right? If we have 8 threads it's very difficult to know which one of those it is. But with 1 thread per sidekick and eBPF, we can say anything that touches this file system, we can find out what the PID of that thing is. And then we can basically tie in a sidekick API call to say what's running on this thing at the moment. In fact, the sidekick process is got, no, it doesn't. Sorry, I'm thinking ahead of myself here. But effectively, we could use the eBPF to kind of trace back between an access and a process, and then figure out what was running when that access happened. It's a little bit more like risky, obviously. It's a little bit less, it's a little bit more future tech, but it might work.
I'm less familiar with eBPF, but can't we inspect the process that is running that made that call and maybe determine which queue that and the arguments associated with it?
No, because so what you'll get from eBPF is you'll get, from the trace point, is that this process effectively PID X wrote to the, like you say, let me know when someone writes to this file system. Yeah. And then you look through all of those and you're like, it matches the directory. Okay, fire off a thing. And the event you get is like a PID, right? So now you're in user land and you've got a PID and a file that was being written. And you've got to map from that to a job.
Worker thread.
And so if you have, and if you don't have a thread, you've only got you've only effectively got a PID. I don't think you've got a thread ID. And also the thread IDs are kind of funny. They're kind of like kernel thread IDs, which are like different, I think. So, but certainly like it's much more agricultural and kind of boring and simple to just say, this process ID is this job ID, okay, like, or this job, and then you could run all of the sidekick jobs on that. But so the second fleet, you just run it for a week, and you're just collecting this every time it logs what happens. You just collect it. Yeah, exactly.
I mean, that makes sense.
It's a bit, yeah.
I mean, that makes sense, and also it could be actually significantly sped up, Scarbeck. I think we could significantly reduce the number of queues by just putting them all on staging, having them fail the way they do fail, right? Like Sentry, like unmount things and then have things fail in Sentry. And that will filter down theoretically significant amount of these jobs. So actually you'll be working on a very much smaller set of jobs to go through the process that Andrew just described. So you won't have to do all of it. So all of the queues, but you first have the approach of, brute approach, and then do the thing that Andrew describes.
So
does that make sense? Sorry, Andrew.
Sorry, go ahead.
Scarbeck,
Yeah,
that makes perfect sense. Like I enjoy this thought right now, because this, as much as I want to move things over to Kubernetes as soon as possible, I don't want to introduce failure. I don't want to do the failure-driven development here. So this would be a good way to investigate things beforehand.
Yeah.
So, I mean, you could, so right now, right, I know that this process, 299444, is writing to NFS. I mean, you could do this with shell script, with a bash script, right? I could do this. You could do it better, and you could get all clever, kind of on the style of Giddly, what's it called? Giddlymon, where we kind of wrote all our own custom stuff. But you know, I mean, here I could do this with a bit of shell scripting, right? Where I kind of pick that out, and then the only trick is. And I know the Sidekick API lets you basically figure out what's running on a particular machine at a particular time. So you know, as soon as you get one of these notifications, you look up what's running, and yeah, you just, it would be, you know, pretty easy. Yeah, but I mean, look here, you know, here it is. We can,
I see.
You know, here are read, write, you know, where is it reading to the file? What's it writing? How many bytes is it writing? We've got a whole bunch of information here. And these are NFS, you know, this is actually NFS traffic. So,
Yep.
Yeah. Something to consider.
I think the combo there, Scarbeck, might give you quite a lot.
Yeah.
Right? Like the naive approach that I'm suggesting, just see what Sentry throws out immediately at you in staging. After you unmounted the NFS from that node, that limits your scope significantly.
Yep.
And then you do what Andrew is describing here, where you can just actually zoom in into each and every one of them and go and find it. That's actually going to be significantly faster. I would go even as far as saying that when you get some confidence, like when running this thing, you might even want to consider confirming with a set of, like you've already explored, right? Like, and you have fair confidence that some of these queues are definitely not depending on NFS. You might even want to consider isolating them and moving them to production to get the new data while you're investigating the rest in staging, right? Like, and do it piece by piece. And then the third approach, obviously, I think is absolutely worthwhile, which should be probably the first approach. Collect all the queues, find all the feature categories, find all the owners, and ping all of them and ask them to do certain things, right? Like, does this depend on NFS? Define what does depending on NFS actually mean.
Yeah, I'll have to spell that out.
Yeah. Andrew already did that successfully with, not NFS, but finding owners for feature categories.
Like I think I 100% agree. Like that's the first thing we should do. My only concern is like the downside of making a mistake. Obviously, if it's one sort of source of information, that's great. But on its own, it's not going to be enough, because with the feature categories, it was really easy to kind of, oh, we made a mistake here, let's change it. But with this, it's like, oh yeah, I didn't actually think about that. Yeah, of course we do use NFS, and that's kind of, you know, there's going to be a lot of those, right? Yeah.
We agree on that.
But I do agree, 100%.
Yeah.
Of course, yeah.
Yeah.
And there will be a bunch of things like
yes,
that.
then we're going to be like, okay, there is a yes there. Like, it depends.
Yeah.
let's move on to the ones that are no, and we can then
Yeah.
focus on those, you know.
Yeah. So I got two things, two questions. The first one is, well, not one really a question, but if someone sets up like a little subfleet that is catch-all low concurrency or whatever you want to call it, like I would be happy to build the script that does the rest. Like I could put something together. I don't think it would take me that long, and then we can just start collecting that data pretty early on. And we can, you know, it'll just go to a file or something, and then we can look at it.
Yeah.
That's the first thing. That's just a comment. But if someone could just set up the low concurrency fleet, that would be super useful. Then the second thing was what do we do with the rest of them? Can we run them on a node pool with NFS access?
I mean, I think we would just leave them on the VMs, right? Like there's no
Why?
use in
Absolutely.
moving those.
Absolutely.
There's no use in moving those to Kubernetes at all.
Why?
Until the
But,
application gets fixed.
Can I dig into that a little bit further?
Yes.
You can try.
So if those machines, if those nodes were like on a Sidekick NFS node pool, the node pool had NFS mounts, and those were shared with the containers that were kind of specifically running those. Is that not a thing?
I don't even wanna consider that. Honestly, that sounds like such a nightmare, Andrew.
This also goes against the grain of the cloud native and our complete end goal for this entire piece of work.
I don't know so many things about that. Like I don't know the performance cost. I don't know like how it degrades. I don't know anything about it.
Yeah, I mean I think there's risk, but then I also think there's risk of kind of like having this fleet splits between the two, and the things that can go wrong with that. So it's possibly something to consider. I know Ben's kind of mentioned it quite a lot. The mount them underneath.
No, thank you. That's the route I'm not willing to support at all. To tell you the truth, like I'm being a bit, prescriptive here, but like we already are dealing with too many unknowns. Introducing yet another level of unknown is exactly what I want to avoid, which is why we are going down this route of like being a bit cherry picky and so on. Anyway, I have to drop out, but hey, Skarbek, feel free to entertain this thought. Maybe there is something to it, and you need to convince me that I'm being silly in a separate call.
All right.
I'll catch you all later.
Bye.
Andrew, I think another situation to consider is the fact that I don't know if anyone on our team has any experience with NFS mounts inside of Kubernetes at all. Like I certainly do not in my history. So like that in itself would require a little bit of research into determining what issues we're going to run into.
Sure.
That,
I'm not saying it's, I mean, like I'm just trying to be pragmatic about like how to get on, right? Because like go back 3 years and this conversation was being had 3 years ago, right? And
I wasn't
if
here
you're
3
trying
years
to
ago.
move,
I just got my 2 notification.
but well done, congrats. But like, let me tell you that it was going on. Like literally this time 3 years ago, people were talking about, we're going to move everything to Kubernetes, and the application's going to be running in Kubernetes. Just great. And here we are. And there is risk, but can I tell you where I see loads of risk is when we go, oh, we're going to roll this back, and then let's get some release people onto the call. Oh, well, we can't really roll this back because like this weird complexity of like the split application and blah, 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 blah.
Completely
it's not a risk-free alternative. It's not like there's no risk, and we see that risk every day when we're trying to do rollbacks or weird shit happens, and anything where you've got to kind of think of these two worlds is risky. And so I don't know. I mean, I'm just trying to look for pragmatic solutions to go forward, right? And if we can get rid of it like really quickly, that'll be awesome.
Yeah, I mean, the sooner we could make any progress as far as getting rid of NFS in general would be helpful. But
but this is a it is a 3-year-old the kind of debacle, right? Like I can show you 3-year-old issues where it's all going to be finished really soon.
Even the
And
infrastructure team says that for stuff.
yeah, of course.
Goodness.
Yeah, I mean, even Pages was going to be finished.
Precisely.
Yeah,
That was supposed
in
to
the
be
middle of
finished right
2018.
after I started.
Yeah, exactly. So yeah, there like I'm 100% agree that there's risk in the alternative, but yeah. Yeah, anyway, I'm more interested in this NFS thing. Sorry, the eBBF thing. I think it would be kind of interesting, and
I am
I
too,
don't
but
think it's that
also
hard.
partially because I don't know anything about that system. I've never used it before. I've only heard about it so far. Being the fact that
eBBF
we
is
install it on nodes
amazing.
is helpful.
Yeah, yeah. Well, that's why I could just log on now and just run NFS slow 0 and just see all the traffic that was happening. Yeah, it's a super useful system.
Okay, so as a short overview, we're going to identify all the queues running in catch-all, and we're going to find owners for those, with the goal of asking, is there
So you know,
an
do you know how
NFS?
to? Do you know there's a YAML file that'll give you the owners?
Yep, but I was going to query Sidekick to tell me which ones are running, and then go through that list. I mean, does that list also tell us who owns a queue?
So no. So what you can do is you can get from Sidekick what's listening, or you can even get
Mm-hmm.
it from like a PS or whatever. You can get that, or there's a Ruby command which is part of the node selector stuff. So if you ping
Yeah, I
Sean,
was just going
the
to do
Git,
like a node selector query against
yeah,
Sidekick to tell
yeah,
me all the
exactly.
queues.
And then kind of what you can do is do the invert thing that we so you do the ones that we've got. That'll give you a bunch of queues. Then the next thing is there's a YAML in GitLab, GitLab. There's actually two. There's an EE one and a non-EE one called allqueues.yml.
Yep.
And that's got one of the things on it. So you need to do a cross join, and that'll give you a feature category. So then you can kind of have the first column, the queue name, the second column is the feature category, and then you can write a little script that'll join that up with stages.yaml, which is in www.gitlab.com. And that will give you the stages YAML. The structure is basically stages, groups, teams, something like that. And
Yeah.
then at the bottom level, there's a thing called categories, and that's what we call feature categories. So effectively what you're doing is you're finding, so say you've got a feature category for this thing to be X, then you go find category X in stages YAML, and that'll give you, effectively you'll be owned by one and only one team. And then on that team, you can either list like the name of the team or the engineering manager or whatever you want. It's all in there. And then you've got it all. I can help you with that if you're getting stuck or anything. I
I'll see
will
if
write
I
it in
could.
JSON, right?
I'll see if I could.
Because it's a really short script. Yeah. In
I'll see if I
JSON.
could figure that out. But
Cool.
if by
Just,
chance
yeah,
you're able
shout.
to accomplish that faster than I am, by all means, have at
If
it.
you give me a list of queues, the queues bit is, actually queues bit shouldn't be too hard. I should be able to do that for you as well if you want.
Yeah, so I also know how to do the feature queue selector query against Sidekick, so I could quickly grab the list of queues that are going to be executed.
Cool.
All the other
And then
stuff,
I can
just a short
give
little
you
script.
the file for that. Awesome.
Cool.
And then just create a massive issue with like all of them in
Precisely.
it. Yeah, and a
Copy
checkbox or
all the
something.
people, and
Maybe
hopefully
2 checkboxes, yes and no. This
yeah,
file has, this queue has NFS, this queue has not NFS.
yeah.
And then I don't know as a fourth option, third option. Cool.
All right.
Okay, cool. Well, good luck
All
with
right. Well,
that.
that's a good plan of action for that work, which is all I really care to talk
Awesome.
about. So,
Awesome. Well, I hope that everyone answers very definitively yes or no, and then there's no other work.
yeah, we'll see. Okay.
Yeah.
Let me stop the recording.
Cool.